In this set of mini lectures, we're going to talk about two methods of propagation: division and then the propagation of geophytes, which actually encompasses several methods used on these special types of plants. So you can see our clever subtitle here, breaking up is not that hard to do. Because actually division is the easiest form of propagation there is. It's very simple, and as such you'll only have a few slides on it. That's why I've lumped it in here together with geophyte propagation. Division is the only option for propagation of some plants. If you remember back to the whole Freaks and Mutants lecture and think about chimeras, you'll remember that chimeras can only be successfully propagated by stem cuttings, layering, division, and grafting. So, for example, your snake plant with the yellow stripe around the leaf margin, if you take a leaf cutting of that plant, you'll get a new snake plant, but it won't have the yellow stripe because the yellow stripe is caused by a chimeric mutation. However, if you propagate those snake plants by division instead, then you will have new plants that retain the chimeric mutation of the yellow stripe. Now, the downside of division is it doesn't typically produce as many new plants from your original stock plant as all the other different types of propagation that we'll talk about. However, it is easy, it requires no special equipment. The main thing you have to remember with division is to maintain a portion of the crown in each division. Alright, so if you look in the picture here, they're dividing this plant. The crown is the area where the roots and the shoots meet, so it's right at ground level. You have to have a portion of the crown on each division. Another way to think of it is each division should have roots and shoots on it. Now, if it's winter and you're dividing it, you're not going to have shoots if it's an herbaceous perennial, but you should have a piece of the crown where the new shoots are going to come out in the spring. So this picture again shows you where the crown is. It's just where the roots and shoots meet. Now you want to make sure you're using a very sharp cutting tool for division so you don't essentially maul your plant, so you get a nice clean cut. And I wanted to add too, division is a form of propagation, and for some plants like grasses and herbaceous perennials, it's also a form of maintenance. If you don't divide some of your herbaceous perennials or grasses, what happens over time is they grow so thickly that they sort of crowd themselves out. It can cause die out in the middle of the clump. So for some plants, you need to divide them anyways just to maintain healthy, vigorous plants. Right, so you can kind of kill two birds with one stone. You're improving the health of your plant by dividing up that thick clump, and you're also propagating and creating many new plants. And this is a situation that for some plants you may get a significant number of daughter plants from division. Think of your ornamental grasses like pampas grass or miscanthus grass. We used to divide those up at the research station, and we actually had to use mallets and machetes because the root balls were so dense. But we could get hundreds of new plants by division through a really large clump of grass. But essentially with division, unless you have a really large dense plant, you're not going to get that many daughter plants from it. Now from there we're going to move on to geophytes. Geophytes are plants that people often put under the blanket term of bulbs, but they're not all technically bulbs. Basically, a geophyte is a plant that survives as a specialized storage organ underground, and this includes bulbs, corms, tubers, tuberous roots, rhizomes, and pseudobulbs. Now, there are different colors there to indicate what type of tissue they are. All the ones in green, so corms, tubers, rhizomes, and pseudobulbs, these are essentially modified stems. They're completely composed of stem tissue. A tuberous root, as you might suspect from the name, is all root tissue, and for the bulb you actually have stem, leaf, and sometimes flower tissue all in your one bulb, so it contains multiple types of tissue. This is important to know because it determines how you can propagate it. So here's your definition of a true bulb. A bulb is a specialized underground organ consisting of a short, usually vertical stem axis called the basal plate, bearing at its apex a growing point or a flower primordium enclosed by thick, scale-like leaves. So you can see just by that definition, again, we have stem, leaf and flower tissue inside of a true bulb. Now, bulbous species are classified in several different ways. One is by their hardiness. If it's a hardy bulb, that means it will survive the winter and it'll come back in the spring. A tender bulb will not. So tender bulbs, if you want to keep them from year to year, you actually have to go dig them back up and bring them inside somewhere warm to overwinter and then plant them outside again in the spring. Of course, a semi-hardy bulb is going to be right in between there. Most years it'll survive outside, but if you have a particularly cold year, it may not. A good example of this is amaryllis, at least for our area here in Raleigh. Amaryllis is semi-hardy. You can plant it outside and it will usually come back year after year, but I'll be interested to see how they do this year because we had a colder winter than normal, and so they may not come back. Bulbs can also be classified by the time of flowering. If you go to buy bulbs, people are going to use phrases like spring flowering bulbs or summer flowering bulbs. It tells you, of course, when it flowers, and it's also important to know as far as when to plant it and what time of year you'll be able to buy it. If it's a spring flowering bulb like a daffodil or a tulip, those are going to mostly be available for sale in the fall, and that's when you want to plant them. And then they'll bloom the following spring. In the springtime, that's when your summer flowering bulbs, things like lilies, for example, are going to be available for sale, and that's when you want to plant them. You plant them in the spring, they flower in the summer. Now, the classification system for bulbs that we're really interested in for the purpose of propagation is that last one, structure. By structure, we have two categories: tunicate or laminate bulbs. Again, those terms mean the same thing, and our scaly or non-tunicate bulb. So let's talk about tunicate bulbs first. Tunicate bulbs are called that because they have a dry, membranous outer scale called a tunic. Think about an onion. An onion is actually an example of a tunicate bulb, and it's got that papery outer layer that you peel off before you begin to cut it up and cook with it. The purpose of the tunic is to protect the bulb from drying out and also from mechanical injury. So tunicate bulbs are a little tougher and often last in storage quite a bit longer than scaly bulbs. So you have the outer membranous dry tunic scales, and then inside you have fleshy inner scales, which are serving the purpose of food storage for that plant. So here I've listed some examples of tunicate bulbs for you: tulips, daffodils, onions, hyacinths, amaryllis, garlic. These are all tunicate bulbs. And here's a cross section of one. So you can see the papery tunic there at the very edge of the bulb, and then the fleshy scales. And those scales are just modified leaf tissue. And then there's our basal plate, which is modified stem tissue. And of course, this thing here in the center is either a flower bud or a vegetative meristem, depending on the time of year for that bulbous species. So in this picture, you can clearly see the leaf tissue, the stem tissue, and the flower tissue that make up this bulb. And with tunicate bulbs, they have the tunic, and then you can see the fleshy scales in a tunicate bulb are arranged very tightly pressed up against each other, sort of in concentric rings. This is another picture of a cross section of a tunicate bulb the other way. So the last one was a longitudinal cross section. This is the other way. I can't remember what that would be called. But you can see here again the concentric rings of the inner fleshy scales. And a lot of the time, tunicate bulbs will actually form offsets. A good example of this is daffodils. They form a lot of offset bulbs. So you have your original bulb and then new bulbs forming right next to it. And you can see the beginning of those offsets forming by taking this kind of cross section. Each little target center essentially is the beginning of a new offset bulb. So in a way, tunicate bulbs actually propagate themselves a little bit. And here's just the same thing, but a real picture instead of a drawing. This is an onion. You can see there's actually 3 little target centers on there, so there's 3 offset bulbs forming in this onion. The other category are scaly or non-tunicate bulbs. Scaly bulbs do not have that papery, dry membrane on the outside, so they don't have a tunic. And the scales are very separate. They're just loosely joined together in a cluster, not tightly pressed against each other in concentric rings like the tunicate bulb. Because it doesn't have the tunic, it's easily damaged and it has to be kept continually moist. You can tell this just when you go to buy them. If you buy tunicate bulbs like daffodils, they'll just be in a bag with no soil or anything. If you buy a scaly bulb, and by the way, that should not be a picture of a tulip there, because tulips are tunicate bulbs, not scaly bulbs. So, just seeing if you guys are paying attention. I just noticed it. So, lilies are scaly bulbs. And in fact, they're the only scaly bulbs that I can think of off the top of my head. But if you go buy lily bulbs, instead of just being in a bag, they'll be sold in a bag with moist media. That's to keep them from drying out and from being damaged. Now, scaly bulbs do have something that tunicate bulbs don't, and that is contractile roots. These are special roots at the base of the bulb that can actually pull the bulb deeper down into the soil. And they, in appearance, are much thicker and longer than the sort of fine, hairy-like roots you'll find at the base of a tunicate bulb. So here's an example of a scaly bulb. This is an Easter lily bulb. You can see each of those scales loosely arranged, and look how thick those roots are. Those are those contractile roots there at the base. This is a Asian lily species. Again, you can see those scales are very loosely arranged. Here's a scale here, here's a scale here. All right, so not nearly as closely pressed together as in a tunicate bulb, and again, no tunic. So those are your two classifications of bulb species. In the next mini lecture, we're going to talk specifically about how that affects the way they're propagated.